Okay, so I'm Dr. Russo. I want to do a quick video and explain our immunity and how it's sort of divided up. Hopefully this will make it clear. We're born with what we call the innate immunity. So innate immunity would be the most, it's probably what we started with, right? This was something that eventually, through evolution, we acquired it. So most animals have what we call innate immunity, where they're just, like say our skin, mucous membranes, they're physical barriers, is another way of thinking of it, that help. But there's also another component to it. There's, like say, we have what's called phagocytosis, right? And that's when white blood cells, right? We have white blood cells like neutrophils that come along and eat a bacteria. Okay, so like that, say that's a little bacteria, then the white blood cell, the phagocyte, comes along and eats the bacteria. Okay, now the big differences between this immunity and say this type of immunity is acquired immunity relies on an antigen, where this type, the innate, is non-specific, right? So antigen is what makes the acquired immunity specific, right? And an antigen is what this immune system is looking for, right? So we normally think of antigens found on pathogens or bacteria that, cause diseases. Okay? So they have like these little markers on there, right? And when our immune system, the acquired immune system, sees that, it goes, oh, we've got a problem, we need to get rid of it. Right? The innate immune system isn't looking for antigens. It's just indiscriminately getting rid of what it thinks is bacteria that doesn't belong in our body. Okay, or a physical barrier that's helping to keep bacteria out of our body. So the acquired, right, relies on antigen recognition. Right? It also has to, there are even antigens in our body, which makes this kind of confusing, right? But the definition of an antigen is just a small, very small piece of a protein. So let's say if this is a protein here, say an average sized protein, the antigen would be just a small spot on the protein. And matter of fact, one protein could have several antigens on it, right? And an antigen is like, they'd be different shaped. They'd be shaped based on the amino acids in the protein at that particular spot. Okay, so think of it like as a puzzle piece. If we put this protein together with puzzle pieces, this might be one puzzle piece, this might be another puzzle piece, this could be another puzzle. All the puzzle pieces are different shaped. Okay, so that's a way of looking at it. So when, let's say a big bacteria comes along and it's much bigger than this protein, it has this antigen on there, then our acquired immunity decides, oh, it goes, we don't want this particular bacteria with this antigen on it. That's what makes it specific. This is non-specific. So we produce an antibody. So we say an anti, and then the anti usually means what the antibody binds to. What's the antigen? Either is it found on, you might call it after the name of the protein the antigen's found on, or you might call it anti-E. coli. If this is E. coli, the bacteria, then you might call it anti-E. coli antibody. Okay, but it's not that specific, right? There could be several antigens on E. coli. You could have anti-E. coli number 1, anti-E. coli number 2, you know, depending on. So that's the antibody, it binds. The cellular immunity, which is part of the acquired, right around 6 months old, it's when human beings begin to start producing antibodies and making cellular immunity. These are T cells that look for a specific foreign antigen, right? And they look for the antigen on one of our cells, right? So we'll call it the host cell. So let's say a virus gets into this cell, right? Let's make it a little like that. The virus is in this cell. A piece of that virus usually makes its way out to the host cell membrane during that process. Okay, and the T cell recognizes that antigen as not being part of the host cell. It's like a foreign antigen, and then the T cell, because of the antigen found on the host cell, the T cell destroys that cell in your body, right? So it's a way of getting, you know, say, rid of virally infected cells. So that's cellular, this is antibody, they're both acquired. It's when your immune system, right, is reacting to a foreign antigen. Now, if you have autoimmunity, then you're making antibodies, or you have cellular immunity that are attacking your cells even though they don't have a virus in them, right? It's autoimmunity, self-immunity, your immune system. So it's real important. We normally leave the term foreign antigen out of the definition here, okay? But that's implied, right? Your immune system, if it's operating appropriately, right, it's generating immunity against foreign antigens. If you have an autoimmune disease, then it's decided to make an antibody that attaches to a protein or an antigen that's always in your body, you know, and that can lead to problems. So I basically wanted to make this video to help you understand the difference between innate versus acquired, how this is non-specific because it doesn't look for antigens, right, foreign antigens. Acquired immunity it's divided into two big categories, and they are always attempting to get rid of a foreign antigen from a pathogen. Now, if you have allergies, right, then you produce an antibody against pollen or something that you're allergic to. Okay, that antibody can stick to that pollen. It's a little more complicated because mast cells are involved, but it's because you're making these antibodies to what you're allergic to that, you know, it's not, the pollen's not a pathogen. Okay, so it's an abnormality. You know, you'd rather not have allergies. You'd rather not make these antibodies to pollen. And if you didn't, you wouldn't have allergies. You wouldn't be allergic to the seasonal allergies. Okay, so anyway, that's it. I hope you enjoyed the video.